Assalamu alaikum. Today we are doing integration of k f dash x upon fx. This is also called integration by recognition. Okay. Whenever you see that it's a fraction and the derivative of the denominator is found in the numerator, and that means you can recognize that the derivative of the denominator is actually the numerator. In that case, you would integrate it like this. You would write ln f of x plus c, because we know that if y equals to ln x, dy by dx is going to be whatever is written with x goes down in the denominator, and then you differentiate it and write it up in the numerator. I can give you another example. Ln 3x minus 5. If you have to find out the derivative of this, you will write 3x minus 5 in the denominator, and then you differentiate it and write it up in the numerator. Now likewise, whenever you see that the um, denominator is there and the derivative of the denominator, we know that the derivative of 3x is 3 and the derivative of a constant is 0. The derivative of the denominator is found in the numerator, and you recognize this. You can write this as ln. The derivative of this, the integral of this is going to be ln 3x minus 5 plus c. Okay. Okay, let's take a few examples. If you look at the first example here, it's x squared plus 2, and we know that the derivative of x squared plus 2 is 2x. That means we're going to write this as ln x squared plus 2 plus c. Okay. If you look at this, the derivative of 2x cubed plus 5x squared, it's 5x squared. Okay, the derivative of this is 6x plus 5. 6x squared plus 10x. Okay, if I see if it's 6x squared plus 10x and the denominator is 2x cubed plus 5x squared. Okay, if I take out 2 as common from here, I'll be left with 3x squared plus 5x here. Okay, that means the only thing which is missing is this 2. Okay, and this 2 actually is something which should be there, but it is not there. Now since you want to put this 2 here on your own, you have to actually cancel the effect of this by multiplying it by 1 upon 2. Okay, so the answer is going to be half ln 2x cubed plus 5x squared plus c. Since you've added this 2 on your own because it was not there, to cancel the effect of this, you have to multiply it by 1 upon 2. Okay. Now in this case, you know that the differential of e to the power 2x is 2e2x, because whenever we differentiate something with e to the power of e, you write down the power as it is, and then you differentiate the power and multiply it by it. So what is missing is actually 2. That means you can additionally put a 2 here on your own, and as a result, to cancel the effect of the addition which you have made on your own, you have to multiply it by 1 upon 2. So you just have to write, in this case the answer is going to be a half ln e 2x plus 3 plus c. Okay, moving on to the next question. We know that the differential of this is going to be 1 plus 2x ex square, which is actually the same up here. So we can write down the answer as ln x plus e x square plus c. Okay, moving on to this example, we know that the differential of 1 plus ex is going to be e to the power x only. There's this 2 additional which is here. If I take this 2 as common out, now we can see that the differential of the denominator is there in the numerator. So you can simply write down 2 will stay outside, ln 1 plus e to the power x plus c. Something which is additional, you can take it out as common. Something which is missing and you're adding something, so you have to divide it here as well, like in this example. Okay, tan of 2x, and you have to differentiate. If you notice, tan is sine of 2x upon cos of 2x. And we know that the differential of cos of 2x is negative sine 2x. Negative is missing. Okay, so if you're multiplying a negative sign here That means you're divided by a negative sign here as well. So the answer is going to be a minus ln cos of 2x plus c. Okay, moving on to tan of 3x. If it is tan of 3x, it's going to be sine of 3x upon cos of 3x. And the differential of cos of 3x is negative sine 3x into 3. Okay, here I've made a minor mistake. Let me just correct that first. The differentiation of cos of 2x is negative sine 2x multiplied by 2. So you have to add a negative 2 here. So you have to multiply it by 2 here. So it's going to be a minus 1 upon minus 1 upon 2 here. Okay, likewise, if you have cos of 3x, we know the differentiation of cos of 3x is 3 sine 3x. 3 is missing from here. Or negative 3 is missing from here. So if you add negative 3 on your own here, if I'm adding a negative 3 on my own, I have to add a negative 3 here as well, just to cancel the effect of this. So the answer is going to be negative 1 upon 3 ln cos of 3x plus c. Okay, moving on to this question, which is similar to the previous one. So let's just leave this. Okay. Okay, let's do some of these. Find the following integrals. 6x square upon x cube minus 1. We know that the differentiation of this is going to be 3x square. Okay. Now, if you notice here, I wanted a 3x square here. Okay. What is additional is a 2. So I can put it outside, and then I can write this as 2 ln x cube minus 1 plus c. This is the A part done. Okay, the B part. The differentiation of 1 plus sine x. Differentiation of 1 is a 0. Differentiation of sine x is cos x. Okay, so the differentiation is up in the numerator, so simply you can write it as, I'm just copying the question, ln 1 plus sine x plus c. Okay, the c and the next part. Okay, the D part now. Cot of x. Okay, we know cot is cos x upon sin x. So we've done this question before, but it was tan of x. Now we know that the differentiation of sin x is cos x. So you can simply write it as ln sin x plus c. Okay, moving on to the next one. Okay, so when you're going to differentiate this, you will get minus 2x. Now what is missing is minus 2. Okay, so I'm going to multiply this by minus 2. So as a result, I'm going to multiply this by minus 2 here. It will become minus 1 upon 2 ln 2 minus x square plus c. Okay. We know that we can also write it like this. We can make this coefficient the power also. So that's also okay, not a problem at all. If you want, you can shift it up here and make it a power. Moving on to these questions where you had to find out. I've done a similar question like this one. Okay, I'm even this one. I'm doing this part here, question number 2. It's x plus 1 upon x square plus 2x minus 1. Okay. Okay, when you differentiate this, what will you get? You will get 2x plus 2. Okay, I want a 2x plus 2. That means I want a 2 up here. So in order to, if I want this 2 here, I can just put 2 here and I can cancel the effect of this here. It will become 1 upon 2 ln x square plus 2x minus 1 plus c. Okay, now I have to put the boundaries of 2 and 1. So I can keep this half outside. Okay. and I can put the boundaries on this. Ln 2 square plus 4 minus 1 is the first bracket, minus ln 1 square is 1 plus 2 minus 1. It's half ln 4 plus 4 is 8 minus 1 is 7 minus ln 2. This can be written as half ln 7 upon 2. This is the answer. If they say write down the exact answer, write down the answer in the exact form, it will be like this. But if in case you want to change it into decimals, you can also do that if there's no restriction. Okay, this half can become the power, so 7 upon 2 to the power of half. Okay, that means you have to take out the square root of 7 upon 2 here. You can either give the answer like this or like this. Okay. Let's do this one. Now we know that the differentiation of 1 minus 2 cos of 2x. Okay, if I ask you to differentiate this, 1 minus 2 cos 2x. Okay, dy by dx is going to be, differentiation of 1 is 0, minus 2 cos 2x. So differentiation of cos is negative sign. So it will become plus 2 sine 2x multiplied by 2. So it will be 4 sine 2x. Okay, fine. Okay, we know sine of 2x is actually 2 sine x cos x. Sine of 2x equals to 2 sine x cos x. And this is 4 sine 2x. So if I have multiplied by 4, so I have to multiply this also by 4. It is going to become 8 10. So in the next step, I'm writing it down like this. 4 sine 2x is equals to 8 sine x cos x. Now what is missing here is actually 8, which is missing. Okay, so if you introduce 8 on your own here, you have to introduce 8 here as well, and it will become 1 upon 8 sine ln 1 minus 2 cos 2x. Okay, now I have to put the boundaries, so I'm keeping the constant outside and putting the boundaries of pi by 4 and pi by 3. Okay, let's put the boundaries. Ln 1 minus 2 cos of 2 pi by 4 minus ln 1 minus 2 cos of 2 pi by 3. Okay. One minus 2 cos of 2 pi by 3. Okay, 1 upon 8 outside. This has become ln 1 minus 2 cos of pi by 2 we know is 0. So 1 minus 2 into 0 is the first bracket, minus ln 1 minus 2 cos of 2 pi by 3. Pi by 3 is 60 and cos of 60 is half. So minus 2 into half. But this is cos of 120, which is negative half, because in the second quadrant cos is negative. So negative and negative will become positive. So we have 1 upon 8 ln 1 minus ln 2. Okay. We know ln 1 is a 0. So 1 upon 8, 0 minus ln 2. Okay, it's 1 upon 8 times negative ln 2. So it will become minus 1 upon 8 times ln 2. Okay, this brings us to the end of this. Thanks a lot for watching the video.